This is concept 4, problem number 2, and this problem is in relation to the previous problem, problem number 1, and it asks the mass of the car is 1,200 kilograms. Determine the centripetal force necessary to cause the centripetal acceleration above. Draw a quantitative force diagram. And in the previous problem, we found that the centripetal acceleration was 4.928 meters per second squared. And it's important to note that the car in the problem is resting at the top of a hill. So, we need to basically find the centripetal force that keeps the car on top of the hill, and we need to find a force diagram and label it quantitatively. And since it is on the top of the hill, we know that force gravity is going to be larger than force normal because the centripetal force that keeps the object within the circle is always pointing downwards towards the circle, and in this case it is force gravity. So we're going to be finding force gravity and force normal. So first we are going to find the force centripetal acting on the car, and to do that we're going to use the equation force centripetal equals v squared times mass over radius. And we have our velocity from the previous problem, which was 11.1 meters per second, times our mass from this problem given, which was 1,200 kilograms, all over the radius from the previous problem, which was 25 meters. And when solved out, our force centripetal turns out to be 5,914.08 newtons. So that's our force centripetal. And we know that force centripetal is basically the same thing as a net force. So in order to label our force diagram, we can start by labeling force gravity, which is going to be the same as the weight of the car, and the car is 1,200 kilograms. So by using dimensional analysis, the force gravity of the car turns out to be 12,000 newtons. So now that we have our force gravity and we have our force centripetal, we can use the two values in order to find the force normal on the force diagram. So we are going to do force gravity minus the force centripetal is going to equal our force normal. So 12,000 newtons minus 5,914.08 newtons is going to equal our force normal. So our force normal turns out to be 6,085.92 newtons. And there you go.